So today our next topic is the method overriding. Method overriding, also known as the runtime polymorphism. Last one session we know the compile time polymorphism. What was the compile time polymorphism? Compile time polymorphism is method overloading, and method overloading is also known as the runtime polymorphism. So what is the method overriding? So in case of method overriding, first point it will implement normally within the inheritance. What inheritance, or you can also use the term that one is a relationship. So always method overriding or runtime polymorphism always implement within the inheritance, and in case of method overloading, this one always within the same class. This is the difference, within the same class. And in case of method overriding, that one is the runtime polymorphism, always within the base class superclass concept. That one is known as is a relationship. And second point, that one is the same name of the function should be same name of the function. In case of method overloading, there also the concept was the name of the function in both cases, or more than one method. If you want to declare, that name of the method should be same. And the third point, the numbers of the parameter also will be same. Numbers of argument also will be same. Numbers of arguments are same. But in case of method overloading, the name are the same, but the signature was different. Signature will be different. Signature means that is your number of argument will be different. Signature will be different. That was the difference between the method overloading and method overriding. So first one, this one will be the inheritance. It will implement within the inheritance, that is the base class and superclass concept, base class and child class concept. It is not be implemented within the same class. Clear? And then the name of the methods all will be same, and the numbers of argument also will be the same. And one more point, the return type also will be same. Or you can use also subtype, or that one is the subtype, which one is also known as this one is the subtype. This subtype is also known as the covariant. Handwriting is not so easy to read. So this one is also, the return type also will be same, or this one you can use the subtype, which one is also known as the covariant. Clear? So if you have, I think that this one you have one doubt, I will clear it afterwards when I will discuss the return type of the methods. So at first, this one is the basic part of the method overriding. I will discuss in this session this basic 4 parts. Afterwards, I will discuss the elaborately our method overriding in one more session. Now, see the example. That one I have one class. That class shape. Within the class shape, I have one method. That one is the method area. Clear? This area method will print that this will print the area of the shape. Now here I declare one rectangle class which will extends from the shape. And within this rectangle method also I have, within the rectangle class also I have one more method. This one is also area. Here you see that first point, which one I declared, that the name of the methods will be same, and that one is the method overriding is implemented within the inheritance. That one is a relationship. This one is the first point, which one I already use, and that name of the method also same, and the return type also same, and the numbers of arguments here you see that one is also same. Clear? This one is a 0 argumented, this one is 0 argumented, and this one is also the 0 argumented, and the name of the method in 3 classes are same, and the return type also same, and this one is totally a example of the inheritance. Clear? So this one is the area method, which will the print of the rectangle, and this one is the area also one more method within the square class, which one is also the child class of the shape, and this area method will print that this one this will print the area of a square. Now how you use this one? Now here you see, here I use one reference, that S1 is the reference, and new shape. Using the new shape I try to create the object. The address of this object will store within the S1. If now I want to call that S1 dot area, so which method will called? Which method will be called? That one is the new shape. That shape class method, this area will be called. This area will be called. So this one will print the area of the shape. Area of shape. Right? Now if I want to create the object of the rectangle class, so how to create? Just like this. If you want to create that rectangle, R1 equal to new rectangle. This one is the child class object, new rectangle. I new within this new keyword I will create the object of the rectangle class, which will the reference will store within the R1 reference. Now if I want to call R1 dot area, this area means this area will be called, the rectangle area will be called. So what will print? That is the area of rectangle, right? So with the help of the child class object, you can call the child class method. The same if you want to create the square class object, then if you want to do that the object of the square class, if you want to call the area, so this one will be called, will be printed. Now maybe if you want to create a reference of the shape class, that one is the shape S1. Now if you want to create the object of the new rectangle, this one is the concept of the polymorphism. So when you do like this, new rectangle, the object of the rectangle class will be created and the address will store within the S1. Now if you want to call S1 dot area, what will be the output now? Now this one is the S1 is the reference of the shape, which will store the address of the object of the rectangle. Clear? So the in the last session I already discussed the what is the object and what is the reference. So with the help of the shape class reference, if I want to call the area, this area means this rectangle class area will be printed. So this one will print the area of the rectangle. Clear? This one is known as the polymorphism at runtime. At the runtime, when you create your object as per your object declaration with the help of your reference, which method will be printed as per your object declaration. So that's why this one is known as the runtime polymorphism. Clear? So next, if you want to if you want to create S2 equal to new square, so if you want to call now S2 dot area, so which area will be called? In this case, that area of the square will be printed. So in this area will be printed void area. This will print the area of a square. So at the runtime, which object we will create and the address of that object will store within the reference of the base class. If you want to call this one, so as per your object declaration, that method will be called. And if you simply this one, if you want to do like this, the object of the rectangle class equal to new rectangle, so obviously this r1 dot area, all of you know the object, child class object will call the child class method. If it is a base class method, so you can call the base class method will be called. And if this one is the child class method, you can call the base class child class method and base class method both if it is an not private in the base class. So this part already we know in case of single inheritance. And this one is the at the runtime which object will be created within the reference variable as per your object declaration, that method will be called. Clear? This one is a simple example of the overriding, and the next session I will discuss the different rules of the method. If your method is a static, if your method is a final within the base class, so what will happen, this part I will discuss in the next session. Thank you.